A scientist from University of Porto and Fraunhofer, Portugal, came up with a great idea: ultra-low frequency magnetic field communication, a wireless communication technology for smartphones based on the generation of low-frequency varying magnetic fields. As most smartphones are already equipped with electronic compasses capable of measuring variations in magnetic fields, these are practically all set to communicate using this technology. So what can it be used for? ULFMC can be applied to a multitude of scenarios, such as indoor location. Antennas installed in the floor, ceiling, or walls of buildings would transmit an in-building unique location ID to a smartphone passing by, allowing it to know where it is. If one combines this ID tag with the last fixed global navigation satellite system position acquired by the smartphone before getting inside the building, this location ID would become worldwide unique. For mobile payment applications, a small ULFMC-enabled payment terminal would transmit a safe transaction ID to the smartphone of a user conducting a purchase. This ID could then be used to comfortably finalize the purchase via internet. In comparison to near-field communication or QR code reading, ULFMC does not require dedicated hardware on the smartphone and is much more user-friendly. Other application areas include access control and personalized location-based advertising. Besides, ULFMC can extend global navigation satellite systems to otherwise unsuitable scenarios such as skyscraper cities with urban canyons or tunnels, and even help people with disabilities. So how does it all work? ULFMC requires three main components: an antenna, which generates a magnetic field when a current flows through it; a magnetic field control module, which drives the antenna and provides the signal for the creation of magnetic field variations. This signal controls the current which is flowing through the antenna, and then a magnetic field with a specific characteristic is generated. The control module, together with the antenna, form a transmitter. A smartphone, enabled with an electronic compass based on a 3-axis Hall sensor, which is able to measure variations in direction and intensity of the magnetic field generated by the transmitter. This setup can then be used to transmit information from the transmitter module to a smartphone. And no, there's no need for dedicated hardware on the smartphone other than the electronic compass that is commonly available in most devices. Fraunhofer, Portugal has applied for a patent, and a team of researchers has been implementing a successful technology demonstrator. ULFMC is also a recognized technology. Recently, it has been awarded the Galileo Master Prize in the European Satellite Navigation Competition 2012 edition. If you want to know more, check us out at fraunhofer.pt or galileomasters.eu.